Hello everyone, welcome to this new TouchDesigner tutorial in the series of the study of generative design. So we're going to continue with the next chapter, that is this one called P.1.2.1, and the name of this chapter is color interpolation through color gradients through interpolation. So we're going to act like this. That will be mouse reactive, so you can have you can control the number of rows with the y-axis and the number of columns with the x-axis. And if you use the 1 or 2 key, you can change between RGB interpolation or HSV interpolation. So the processing sketch is this one. These are the results. Wait a second. These are the results, and this is the HSV interpolation with the key 2 key, and this is the HSV interpolation with the 1 key. So we're going to end with something like this for this tutorial, and you can see that we are having the same output of colors. As I said before, these sketches are already available to download in the derivative wiki. There is this package of generative design, but if you check it out and look at these talks for this chapter, you will see that this is done, the interpolation is done, but it's not done to have the same output as processing. So I've been studying this book to have the best and the almost the equal approach using TouchDesigner operators or Python code. So we're going to start. So at the end we're going to have this network, something like this. Okay, so I'm going to put this aside in case I forgot something. But we're going to start with this new file. So first we need to know what is our size, 800 pixels by 800. So we change to that size, and we look to bg. So it would be /.bg. Oh, sorry, this needs to be in lowercase. bg. Sorry for that. Next I'm going to show the panel to see what we are doing. Network pane, and I'm going to put it right here. I'm going to add a null, and this null will be our bg. Okay, so we're going back to the processing sketch. We need to you can see here that if we make a left click, you have a new random color set, and the position of x is the resolution of the interpolation, and the position of y will be the row of the count of rows. Also with 1 and 2 we're going to switch interpolation style. These are not useful for TouchDesigner, so we can start by setting our steps or rows and columns for this interpolation, and we can do this with a panel chop. We need to select inside U, inside B, and select. So inside U we can rename it to mouse X, inside V to mouse Y, and select, leave it as it is. Okay, from here we can another select and select mouse X, copy and paste, change to mouse Y, and copy and paste and delete and change to select. Okay, so for mouse Y, we here in processing, the interpolation is done with the map function, that is mapping the value of mouse Y from 0 to width to 100. So we could use this same expression of width, but as touch designers get these interactions normalized, so it will be from 0 to 1 in X and from 0 to 1 in Y. It doesn't matter which resolution you have here. So this is saves us a lot of steps. So we can go right from here with a math. This math will be range from, we say, from 2 to 100. And here we're going to add a math, but we need to remember that to have the same interaction as processing, we need to invert this value. So first we need to change our range from 0 to 1 to 1 to 0, and then from here now we can do this sorry, this range now good from 2 to 10, as is it here. So you can see now we have these values, and we can avoid having these floats, changing in the up page the integer to whatever option you want here. So I'm going to choose round. So now we have our nice values. Okay, we add a merge, and finally we can add a null. Okay, so also we can just make this interaction also, and this helps us with a count, so we can count every time we make this select active, and this will help us to change our noise seed. So it's the only thing we need here, really. So I'm going to add it here to the merge, and now we have these first interactions. So from here we can start building these interpolations. So we need to note that we have to make the interpolation from the color mode that is done or declared in the draw here in the setup function of processing. So we're going to add a noise channel, because we're working with noise also, and you can see it here. So every time I change with my left click a new random color set, is doing this this function that is named shade colors, and we can see here the ranges we are having to have the output we saw before. So the first for H we have a random value from 0 to 60. From to S we have a random value to 0 to 100, and to B we have a constant value of 100. So here we can first change the name. So this is H. The this length is defined by our mouse Y, because we're making these columns from the first from the left color, that is this color, and from the right color. So we make these columns and then interpolate with the value of x. Okay, so we change it here to samples, and we need to remember to delete one because we're using Python. Okay, so as you can see, now we have 9 columns, and sorry, 10 columns that are these ones. Okay, so this is our value for age. We change here to noise to random, and remember we need to change our amplitude to 0.5 and our offset to 0.5. So every time we have a new seed or value, we always be between 0 and 1. Here we can also start using our mouse interaction. So we drag and drop this select to this noise seed. So as you can see, every time I make a click here, it changes its seed. Finally, we can change, add copy and paste this 2 times. So this will help us to avoid some steps and change our name to S and to B. Okay, so as you can see, also here is happening something. We are having the same seed, so as these are pseudo random numbers that are controlled by seed, if you have the same seed, you will have always the same values. So this will produce an black and white image, and we don't want that. So you can use here any expression. So you can add 15 to the number that it is, and you can rest here like 50, maybe, I don't know, really doesn't matter the numbers you choose. The important thing is that every time you click here, you will see these 3 channels in different values. So from here we need to use math to make our interpolations or random values. So for age, remember we need a random value from 0 to 60. So we need to divide those values that are seen here by the number of the total amount of the range of the age or the hue value, that is 360. That is this the same as one cycle one. So we need to get this as we're converting this 0 to 1, that is in this case normalized values, to our values in the same normalized aspect, I think, but with different value for for the top or for the one. So and let me show you this. So here my first range will be 0 divided by 360, that is our color select, and here will be 60 divided by 360. So now we are in that range because our full range is 360, and we are going from 0 to 60. Okay, then in the next 2 values the maximum is 100, so we can use also this as 0 to 1. So this random gets or stays the same because it's going from 0 to 1, and this one is a constant value in all of the colors. So we can also use this math with the same parameters to make this a constant, so we can avoid changing this to a constant and something like that. So finally these are our colors, so we can use a merge and see that we have the values for each color. But these colors are in a row way, so we need to convert it as a column. So we can do this with a shuffle. And shuffle, we're going to split all samples, and you can see here that all samples are in a continuous way. So first we saw H, S, and B, but we need having a set of three that will be H, S, and B, H, S, and B, H, S, and B. So every three will be a pixel value. So we can do that with a reorder. And this reorder, we can change it here to every end channel. Okay, so if you see this here, it will change, and this value is decided by the number of columns, sorry, of rows that we are having with mouse Y. So we drag it here, and now we can see that it doesn't matter what interaction I have, I will always have, after doing this, my first set of HSV, HSV, and HSV. So for now, that's it. So this is, sorry, I'm going to connect a null, and this null we can name it colors left, and we can start visualizing this with chop 2. As you can see here, this in a column way, and our data format to RGB. And here we change our viewer smoothness to nearest pixel. Okay, so here are the first colors that are showing. Remember that we have these colors. We are doing this operation in the HSV area, so these are a color, but this information is given us by HSV value, so we need to convert it to RGB to see the real colors, and we can do that with an HSV to RGB. So here we change again our nearest pixel, the input, and the viewer smoothness, and you can see now the colors that are the colors that we need to see in reality. Okay, so after this I'm going to add a null so we can visualize this better. Okay, so this is our colors to the left, and we need the right color, and then do that interpolation. Okay, so these colors right, we can avoid all the steps we did here, because we can copy and paste this, put it like here. I'm going to come this, and here we only need to change these max values. So first, or random or range or age will be from say 160 and to 190. Okay, so here 160 and 190, and here our value is constant, and here is a random value from 0 to 100. In this case, these are invert. So here I'm going to from 0 to 1 to 1 to 1, so this makes a constant, and then here I can go back to 0, so now I have this change. Okay, and as you can see, now the colors are the new colors we need for the colors right. Here we can change to colors right. Remember, when you change a number, that something that is exported, we need to change yes to all, because if you don't change this, it will have some reference problems, and you can't see your information right. So yes to all. Now we're good. So we're almost there. So we have our colors for the column right here and our colors for the column of this. We can also start seeing this, and we can do this again, converting this information to sorry, to top 2. In the top 2 we can get this alpha channel because we don't need it, and to crop we need to crop full image. That basically is almost this value, but it changes. So okay, we have this color, and I can copy and paste this, and now just drag this null right here. So this top 2, and from image will be null 3. Okay, so now we have our colors, and to make this interpolation we need to change it to this chop values. So first we need to add this together, and we can use this with a join. So as you can see, we have channels that are one sample, and this is that are one sample, and now when we're joining, we have a chop with 2 samples per channel. So now we can also use this connect a null and start seeing from here our result. So I'm going to add again a chop 2, then to RGB data format, here nearest pixel. Now we have our columns, right? Finally I can connect this to my BG. Let me see, sorry, here is point/BG, and now it's working good. So as you can see, we have these colors for the left and right, but we are not making any step or interpolation with the interaction in X. And this is easily done with a stretch. That basically what does this is adds more channels between the values from your first values and the second ones. So you can see here how we can add these samples. So we need to add here my mouse X to the end. Okay, so now we start seeing something very, very cool, because this looks like the output on processing actually, right? Okay, so we're almost there. The next thing we need to do here is to make the second interpolation, or to make active these interpolations. So I saw that one interpolation is done before the sorry, also one conversion to RGB is done before the interpolation, and the other one needs to be done after the interpolation. So here I can add again an HSV adjust to RGB, sorry, an HSV to RGB. We're going to common and interpolate nearest pixel, and now you can see that we're almost having this same output, but we need to bypass these first conversions. So now we have the right output for the second interpolation, that is this one. You can see almost the same. Okay, but if I press 1 like I'm doing right now, it won't work. So we need to use keyboard in and some Python, because this parameter bypass can be done with chops. So we need to bypass or unbypass using Python code. But the code is really, really, really simple. So we're going to add here a keyboard in. We're going to select keys 1 and 2. Then we connect a logic. This logic will help us to make these keys like if they were radio buttons. So just one can be active at a time. And then to avoid working with two channels separately, we can use a fan. So we can convert these two channels to just one channel, to the operation, to changing the operation to fan in. And now you can see that I can say if I'm in the value 0 is because I'm in pressing key 1. If I'm in the value 1 is because I'm pressing the key 2. So finally we add here a null, and after this null we can add an chop execute. So this chop execute, I will choose this or I will leave it like it is, this value change, and we're going to put our code. So remember, if we are in the first interpolation, we need to bypass this one and unbypass this and this. Okay, so every one of these operators have the same name. It only changes their digits. So I'm going to open this in an external editor, and here and on value change we're going to use this val, because we need to monitor this value. So if val is equals to 0, so here we can comment if press 1 go to short interpolation IGB. If val is 0, we're going to put up HSB RGB1 dot bypass, and here we can use ints, or we can use bools. So whatever you want, we can do it the two ways. So this bypass will be false, and then just we need to copy and paste this one, because all of them have the same name, just to change this digit. So for these first two, we need to be false in bypass, and the next one, that is the third, we need to be true. And for the next value, we can just copy and paste. Also, with the comment, we can copy and paste it here. So if I press here now 2, go to large interpolation, that this will be HSB. Okay, so here we need to only invert these ones, and we can invert it maybe like using ints. So if it's false will be 1, because the inversion from false is true, and if it's true it will be 0. So I can save this, and now I check that this chop execute is updated. And sorry, here I forgot to change this veil. That's because this did not working well to perform. So here, if it's equal to 1, now make this right. So now if I press 1, you can see it here. I will always stay in the first interpolation, and if I do clicks, it will change. If I press 2, I automatically change to the second interpolation. That is the this HSB interpolation. So I think this is it for this tutorial. Very, very helpful, very, very funny, I think. Or here you can change your values like wherever you want, and you will have now different interpolations. You can also play with these values for these ranges from saturation and brightness, and you can see how they start changing. Remember, you always need to be in values from 0 to 1. So here also, if you lower this, it will change, but I'm going to leave it like the original one. So yeah, that's it. I just want to show you another things before we leave this tutorial. So the things I want to show you is because I'm working on some things for my Patreon subscribers. I want to thank you, all of you, because you are supporting me uh, make this. So you will have this file in Patreon. So this is the first one, that is what we did right here. You can see it. Then this second one is the same output, but this is an optimization, sorry, because well, here I made some different uh, behaviors, but let me just show you. So 0, 60, 0, 1, 160, 190, 0, 1, and yeah, that's it. So this is an optimized version, so you can avoid using lots of these operators in a better way. And this I made also this tool. This tool helps us to explore these gradings that we are doing here. So there is those two things that we can do here using a lookup to a noise, or sampling these values from or pixels that we have here. So if you are interested, you can support me on Patreon and get these valuable files. So oops, sorry for that. I think that's it, and thank you for all your help, and any comment or you can leave it in the comment section, and I will see you in the next tutorial. And thank you for everything. See ya.